Hi everyone, it's Mr. Jensen. Today I'd like to talk about a phenomenon called orographic lifting. And to do so, there's a really good example of it on the west coast of the United States in the Rocky Mountains. So let's head over to the west coast of America, zoom in on Nevada and California, or generally this area. All right, so you guys will see that we have these forests all across or all along the Rocky Mountains and on the west coast towards California. You'll see that west side of those mountains are lush with forests. If I zoom in, you'll see like that greenery. Then on the east side, you'll see that it's more of a desert area, especially going into Nevada. All right, so maybe just to see it a little bit better, we'll go to the screenshot I took. And so all along this area here, kind of like all of the Rocky Mountains, you'll see that it's nice and green, but on the east side it becomes a desert, and on the west side it's nice and green. So why does that happen? So why would something like that happen? So here we have like a cross section of it, California on the left side or the west side, and Nevada on the east side or the right side. And what happens is, prior to this, we learned about land breezes and sea breezes. So California has the Pacific Ocean, right? So the Pacific Ocean has a general sea breeze that happens often. And so it pushes air into California and pushes air towards this mountain. Now when it hits the mountain, it has nowhere to go, so it's forced upwards. When it's forced upwards, the water vapor in the air gets too cold and condenses when it reaches the dew point. At this time, we'll have clouds on the the west side of this mountain range. And here, the air, or the clouds, will release all the water vapor into droplets called rain, or any precipitation. Now, the air keeps going, and it's nice and cool, so if it's cool, it should sink, right? Cool air sinks. So on the other side, the east side of the mountain, the air sinks down. But when it goes down, it gets warm. So why would it get warm here? That's because this area is like a desert, so I'm going to draw some sand, right? I have that cactus. And so the sand is really, really hot. So when it comes down in Nevada, you have dry, warm air. But in California, on the west side of the mountain, you'll have cool and wet air. And this whole thing together we call orographic lifting. It's when a mountain forces air to move up, and when the air moves up, it expands, cools, and condenses and makes clouds. All right, so here's another general review. This is the more general idea. It's called WRECCC. This doesn't necessarily have to happen at a mountain. On the mountain, it's specifically called orographic lifting because air doesn't need to be warm. Air needs to be pushed up the side of a mountain. But in general, on a normal day to make clouds, we call it WRECCC. So WRECCC because WRECCC. So warm air rises, expands due to low pressure, cools due to low temperature, condenses at the dew point, and will make clouds. That would be like your average day. And once again, it's called WRECCC. Warm air rises, expands, cools, condenses, and makes clouds. All right, thanks for watching.